Fire alarm wiring. In this presentation, we're going to be looking at Section 32 and fire alarm wiring standards. Section 32 covers fire alarm systems, smoke alarms, and carbon monoxide alarms, as well as fire pumps. We're just going to look at the rules that are related to the installation of the IDC and NAC devices, as well as SLC devices in a conventional or an addressable fire alarm system. We'll start at the very top of 32100, which indicates that insulated conductors shall be of copper and have an ampacity adequate to carry the maximum current that can be provided by the circuit. Now, this is determined by the number of devices that we connect on a loop, and the wire size is then calculated with tables from the fire alarm manufacturer. Subral 2 indicates that optical fiber cables are permitted for use in data communication links between control units and transponders of a fire alarm system. Subral 2 fiber optic would really only be seen with an addressable fire alarm system that's quite large. And we can see here a little excerpt from a specific manual for a fire alarm company, and it's showing the connection between different fire alarm panels with a connection of fiber optic. So usually this is only with larger systems. Subral 4 indicates conductors shall have an insulation rating of not less than 300 volts and minimum sizes. So the minimum sizes are the absolute bare minimum that would have to be looked at when determining the size that you're going to install for the fire alarm system, and they have to do with the way in which the conductor is installed. If it's pulled into a raceway, laid in a raceway, or part of a cable, which is what C and D are indicating. Now, it's important to understand that to any fire alarm panel, be it addressable or conventional, there are two general categories of equipment. The first one is the notification devices, which have a high current draw during alarm operation, and the detecting devices, which have very little current draw during operation. NAC zones will often be wired with larger conductors due to their higher current draw when compared to the detecting devices. That then brings us to the type of cables and conductors we'll use. If we go to 32102, it's the wiring methods for a fire alarm system. And in Subral 1, it indicates all insulated conductors of a fire alarm system shall be installed in a metal raceway of the totally enclosed type, in a cable having a metal armor or sheath, in rigid non-metallic conduit, or EMT, where embedded in at least 50 millimeters of masonry or poured concrete. Electrical non-metallic tubing, not EMT, non-metallic tubing. Now, what I would categorize Subral 1 as is for buildings that are constructed with non-combustible materials, and that would be stuff like concrete and steel. These always require armor cables or conductors in conduit as per Section 12, and this is because wiring is often surface mounted, exposing it to mechanical damage. So for combustible constructed buildings, Subral 1 is used. So what types of cables and connections would we see? Well, on the left-hand side, IDC and SLC loop wiring would have FAS cable used. FAS is fire alarm signal cable. It's a red jacket cable with two or more multi-conductors or conductors inside it that are copper, and the system is intended for use with fire alarm systems. You can get it in normal, shielded, and armored. And it really does depend on what your wiring method is as to which one you're going to select. Now remember, from the rule, it says that they would have to be inside a conduit. So if we're using this, a unshielded or shielded with no armor, these two would have to be installed in EMT. If we look at the right-hand side, this is for the NAC wiring. Now, NAC wiring is typically 14 og and larger, and that's due to it supplying loads. And those loads are going to be a fair distance in between each other and the supply, and so we have to accommodate line drop. So, due to their relatively high current, we don't typically use FAS cable to wire them. Instead, BX or EMT with simply RW90 single conductors inside it are used. Now notice, we usually try to adhere to the coloring necessary for the type of electrical system we're installing. And for NAC circuits, that'd be red and black for the loads because it's a DC system. On IDC or SLC loop wiring where we're using FAS cable, if you get two conductor cable, then it comes in red and black. But as soon as you get more than two conductors, they use different colors to try to distinguish and identify them easily. And so phase taping or anything like that typically is not done, and we don't worry about it in the really small gauge wire. Remember, if you're using the unarmored FAS cable in a non-combustible constructed building, you would have to ensure it's run inside some form of a raceway. Typical would be EMT. Now, if we look at subrule 2, it says notwithstanding subrule 1, insulated conductors installed in buildings of combustible construction in accordance with section 12 shall be permitted to be non-metallic sheath cable, fire alarm and signal cable, or installed in a totally enclosed non-metallic raceway. So, this rule, subrule 2, is specific for buildings constructed with combustible materials such as wood, and they do not require armored cables or conductors in conduit, as per section 12. This is because wiring is usually concealed permanently behind the finished covering of the walls, preventing any exposure for mechanical damage. So the types of cables we would expect to see in this type of situation would be the same type of FAS, unshielded or shielded, but they don't have to be armored. Again, this would be for the low current IDC or SLC loop wiring. On the other side, this would be the non-metallic sheath cable. This would typically be for the NAC loop wiring. And you could use just standard Lumex, or you could use this one. This is called HEDEX in the field, and the only difference is that it's meant for a 240 volt AC circuit, which means it has red and black. Now we're using it for a DC system, and so it helps that the coloring is correct, and it helps to distinguish it from some of the other normal building wiring that might be in the condominium. And so often contractors will elect to use this red jacketed HEDEX for the NAC system wiring of a fire alarm system. 32102 subrule 3 indicates the insulated conductor shall be installed to be entirely independent of all other wiring and shall not enter a raceway box or enclosure occupied by other wiring except as may be necessary for the connection of. So things like this, point of supply, obviously the fire alarm panel needs 120 and it needs the fire alarm wires. A signaling device like NAC, maybe to a addressable module, needs both a DC or maybe a 120 volt for the booster panel. Ancillary device, that would be for something like the controls of a fire door. And then they say communication equipment, and they're just covering all the bases. To try to ensure that things are kept independent, often you will be required to put in different colors of cover plates, boxes, or connectors. Sometimes even they'll ask for just a strip of phase tape, red, at the beginning and end of every fire alarm conduit. Now, this isn't a requirement as per the Canadian Electrical Code, but it does make the wiring inside the conduit obvious that it's fire alarm. Therefore, most people will not use anything else or try to pull conductors into that conduit after installation. 32104 has to do with equipment bonding. All of the metal boxes that we use for fire alarm system wiring, even if they're only used for the really small FAS cable, still need to be bonded to ground, and that's usually through a bonding conductor inside the FAS cable if it is unarmored or armored, and if it is installed in EMT, then the EMT connecting to the box with a standard box connector would fulfill the requirements of bonding. And of course, the bonding would connect all the way back to the main fire alarm panel. 32106 illustrates or describes electrical supervision. And it says wiring to dual terminals and dual splice leads shall be independently terminated to each terminal or splice lead. And so this is really everything that we learned to do with conventional systems. If it's conventional, then we need to ensure that all of the wiring is done independent. Therefore, if one of the wires comes off, the fire alarm panel will recognize that change in state and go into trouble. 32108 is for power supply systems. The power supply to a fire alarm shall be provided by a separate circuit. So we usually have a 15 or 20 amp 120 volt circuit. And then it says, where you have a fire alarm with more than one control unit, so that would be something like a booster panel, then of course you're permitted to have a separate branch circuit to that object. In addition, subrule 3 indicates that the overcurrent and And disconnecting means for a separate circuit supplying the fire alarm shall be clearly identified as the fire alarm in a permanent, conspicuous, and legible manner. And it says the disconnecting means shall be colored red and be lockable in the on position. I'll be honest, I haven't seen a whole lot of fire alarm breakers that are actually red, although they do manufacture them. You can see this one here. Often I have seen things like this where there's a locking mechanism, but it's the different from a standard lockout. We're locking it on. And so that is to prevent the breaker from accidentally being turned off. Finally, don't forget there are many other standards. ULC standards govern the majority of the requirements for locating individual fire alarm devices, their heights, their distances to windows, from the walls, above floors, from other devices. They're all covered in this document. If the specifications of the job do not indicate these specifics, the ULC standard is then referenced. Quick lookup charts can be found online for most common fire alarm devices. And so I've got an example or an excerpt from uh, one of those charts, and this is also provided in the course, so you can find this document and take a look at what some of the distances are. Finally, Class A, conventional DCLA, and DCLC. There's a return and a supply conduit. Those two conduits have the supply and return conductors within them, and they need to be in separate conduits. We couldn't take the supply and return conductors back to a 4x4 here and then run them both in the same conduit back to the fire alarm panel. Now, this requirement is given under the ULC 2014 AMD1 standard. Now, you don't have to memorize the standard, but you do need to remember this one important aspect. When you're dealing with a Class A conventional, DCLA, or DCLC, you need to keep the conduits separate, and the separation distance is dependent on the conduits being run horizontally on the same wall or vertically on the same wall. If they're run on the same wall horizontally, you must maintain a separation distance of 1.2 meters. Otherwise, maybe just run the conduit on a different wall or a different location of the building. When you come into the panel, they have to be at least 300 millimeters separation when they're run vertically between floors and things like that. And that's because we don't want them too far apart. Usually penetrations in a building floor are done in the same location, so they shrink the distance. The importance of this is not to do with communication interference, but rather by separating the conduits, you lessen the chance that if a mechanical injury were to take place on the wall, it breaks both lines of conductor at the same time. If you have a minimum separation of 1.2 meters, it's highly likely that only one conduit would then be injured and severed as opposed to both. And that allows for the system to continue operating.